So we are starting the topic 3 or chapter 3 today, and it deals with transformations. Before fall break, we did the tessellations, which was a translation transformation, which means you slide it. Okay? You drew the picture and you slid it to match it up. Today, our transformation is the reflection. Now, what is a transformation? A transformation is a change in the position, size, or shape of the geometric figure. The given figure is called the pre-image, and the resulting figure is called the image. A transformation maps a figure onto its image, and prime notation is sometimes used to identify image points. What does that mean? Okay, so you start out with an image, and that is called your pre-image. Okay, that's what you start out with, and this is a triangle XYZ. Okay, this is a reflection, so you take it and you flip it or reflect it over a line of reflection. Okay, and we'll talk more about the line of reflection in a minute. But the line of reflection acts as the perpendicular bisector between the distances of the points, okay? So the distance between y and the line and y prime and the line has to be the same. And we'll talk more about that in a minute. But you take and you flip it over. Now see, when you flip it over, the y becomes y prime because that's its new location, okay? The x becomes x prime and the z becomes z prime, okay? And so this right here, you would read that triangle XYZ maps onto triangle x prime, y prime, z prime. Okay, so this is a reflection. Okay, now a special type of transformation is one that's said to be rigid motion. And rigid motion is when a transformation preserves the length and the angle measure of the figure. Okay, so looking at these, the first ones, is this a rigid motion? Now it can be reflected, it can be rotated, it can be slid. So yes, this one to me looks like it was totally rotated, okay? But the size and the shape doesn't change. They're indistinguishable, really. I mean, you could take and match one up on the other, okay? And so that would be rigid motion. But if you look at the second one, it's the image is smaller than the pre-image. This is actually called a dilation. We'll talk about those too, okay? So this one is not rigid motion. So this one, yes, it is, and this one, no, it is not. Okay. So we're talking about reflections, and the reflection is transformation that reflects each point in a pre-image across a line of reflection. And my blue line in here is my line of reflection. Okay, and like I said, the line of reflection acts as a perpendicular bisector between the pre-image and the image points. Okay. Now, point A actually lies on the line of reflection. So when it reflects onto itself. So A and A prime are the same point. But if you look at, let's say, B, if you take and reflect it over, see how the distance between B and the line and B prime and the line is the same? And that line is perpendicular to the line of reflection. Okay? And that always has to happen in order for a reflection to work, in order for the pre-image and the image shape to be exactly the same, okay? And again, the C, if you look at its distance to M and C prime and its distance to M, it is the same, and that length right there is has been perpendicularly bisected, okay? So that's what has to happen. Now, the reflection of triangle ABC across line M can be written like this. And so this is how our book writes it. The book I had last year did it a little bit differently, and the worksheet that we're going to do today does it a little bit differently, but they all mean the same thing. We'll talk about the differences and how they're also the same. So this is the reflection over line M of triangle ABC equals the triangle A prime, B prime, C prime. That's how you would read that, okay? And this right here will represent, the little M will represent the line. Like it might be a specific line, or it might be the x-axis or the y-axis, okay? And we'll talk about that, all right? So again, you have, in order for a reflection to be rigid motion, you have to preserve the length and the width. All right, so we're going to do one. It's not going to be perfect, but we're just going to kind of talk about how it has to work, okay? We could do it, and I could make you use the protractor and the compasses and stuff, and that would be very tedious, and we're not going to do that. Okay, so we're going to take and we're going to reflect over this line L, which means I have to draw a line segment from H to the line of reflection and then a congruent line segment on the other side. And this line that I draw has to be perpendicular to the line of reflection. Now again, it might not be perfect, but I'll do my best. Okay, so we're going to go from H to line L, and then we want to try to draw a line that's about the same distance, okay? And we will call that H prime. Then we're going to do the same thing with G. We're going to draw a line. We're going to try to make it perpendicular, and then I'm going to try to make a line congruent to that, okay? And that is going to be G prime, okay? So these need to be perpendicular, and they need to be the same length. And then the same thing with F. Again, I'm freehanding this, so does that look about the same length? Okay, so that would be F prime. So when I drew it, I went a certain distance perpendicular to this line, and then I went that same distance on the other side, okay? So if I draw this, then my triangle, F prime, G prime, H prime, should be exactly the same, except it's reflected. Now, it's not perfect, but you get the idea, right? Okay. A lot of times it's important to look at the letters because that tells you, where this maps on to the image, okay? Okay. Any questions on what I did there? All right. Now, we're going to actually do one here. It says triangle JKL has coordinates J, which is at 0, 3, K at -1, -1, and L at -6, 1. And I've already graphed that for you. Graph and label the triangle and its reflection over the line x equals -4. Okay? So, you have to remember how to graph x equals -4 because that's what we're going to reflect over. Okay? So, x equals -4. What kind of line is that? It's vertical, right? X and half is a B, so it's vertical. And it goes through -4, okay? So we go over 1, 2, 3, 4 to the left, and we draw our line of reflection. And this is x equals -4. Okay. So now what I want to do is I want to reflect over that. So if I'm 2 units one way, I got to go 2 units the other way, okay? So let's start with L, which is 2 units to the left. So if L is 2 units to the left of that line, I've got to go 2 units to the right. Okay, and that's going to be L prime. If I look at J, J is 4 units to the right, so I now have to go 4 units to the left, because it has to preserve that distance from the line of reflection. And then K is 3 units to the right, so when I reflect over that line, I go 3 units to the left. Okay, and so then I draw my line, and it's reflected over that line x equals -4. So that's what you're reflecting. Questions on what I did there? What would a line like y equals -4? What would it look like? It would be horizontal to -4, okay, on the y-axis. All right. Now we're going to do some more reflections. In this first problem, we have a quadrilateral, okay, and it wants us to graph and label its reflection, and then it wants us to come up with a rule, all right? So you got to kind of be paying attention to these coordinates, because some of these reflections have rules associated with them. So notice here, it says reflect over the x-axis, okay, and here's the x-axis right here. So this is what we're reflecting over. All right. So I look first at J, and what do I notice about J? It's on the line of reflection. So its reflection will still be on the line of reflection. Yeah, it will still be on the line of reflection. So that's J prime. So it has the same coordinates, -2, 0, and that's J prime. Okay. Now I look at F, and it is 1, 2, 3 units above. So I've got to go 1, 2, 3 units below. So that is going to be F prime. Okay, and so those coordinates are 0, -3. Okay, let's look at G. G is 1, 2, 3, 4 units above the line, so when I reflect it, it has to go 1, 2, 3, 4 below the line. So that is 2, -4. Do you notice what's happening? The y is changing signs, isn't it? Okay, let's see if that happens when we do h. H is 2 units above, so when you reflect it, it's going to be 2 units below, which would be 4, -2. Okay? So it looks like, go ahead and draw it. We reflected over the x-axis, right? So, if we reflect over the x-axis, we're doing FGHJ. Then it is let's just put XY, that'll be easier. Okay, so if we reflect over there, then my X stays the same and my Y changes signs. Okay? So if I reflect over the X-axis, I take my original XY and my X stays the same and my Y changes. So the opposite letter changes signs. Okay? See what I did there? Alright. Now let's talk about what happens when you reflect over the Y-axis. Okay? Here is the Y-axis. And so this is what I'm reflecting. Stay skinny. Alright, so I've already graphed FGHJ. I think it's the same points, okay? And so now I've got to find the coordinates for F prime, G prime, H prime, and J prime. Okay? Alright, so if I start with F, what do we see about F? Yeah, it just reflects upon itself, right? So it's still going to be 0, 3. G is 2 units to the right. So when I reflect it, it's going to go 2 units to the left, which would be G prime. So that's at -2, +4. H is 1, 2, 3, 4 to the right. So I have to go 1, 2, 3, 4 to the left. Okay, and that is at 4, 2. -4, 2. What do you think is happening here? The X is changing, isn't it? Okay, so what do you think J is going to be? 2, 0, right? Well, let's check it. 2 to the left, we go 2 to the right, absolutely. It is 2, 0, okay? Alright, so I have reflected over the y-axis. Okay? So reflection over the y-axis of my coordinates, you change the x, but the y stays the same. Alright, now this next one's tricky and there's kind of a lot of parts to it, so stay with me, okay? Well, once we get through it, you're going to see that the rule is not so hard, but they want you to discover the rule. And, alright, so we want to describe a reflection on the coordinate plane. Okay, what is the reflection rule under triangle KLM and its image? Okay, so we have triangle KLM and it's been reflected, as you can see. So K maps onto K prime, L to L prime, M to M prime. Okay, now remember when you reflect, that line of reflection has to act as the perpendicular bisector between these links, between those points. Okay, and so if it has to be the perpendicular bisector, what I'm going to do is find the midpoint of 2 of them. Okay, and if I find the midpoint of 2 of them, then I can find the slope, and then I can come up with the equation for the line that it reflects over. Okay, and then we're going to talk about what the rule is. All right, so we're going to start out by finding. We'll use the first 2 points. We're going to find the midpoint of the first 2 points. So we want the midpoint of K prime. Now remember, what do you do to find midpoint? average of the endpoints. So if you average something, you add them and divide by 2, right? Okay, so I'm going to take my x's and add those together. Negative 3 plus 5 divided by 2. And then I'm going to take my y's, 5 plus negative 3 divided by 2. Okay, so this is going to be 2 divided by 2, which is 1. And this is also 2 divided by 2, which is 1. Okay, so that midpoint between where we did k, right, is 1, 1. Okay, all right. Now we want to do the midpoint of L and L prime. Okay, so again, we add the x's together. 1 plus 3 divided by 2, and 3 plus 1 divided by 2. And that's 4 divided by 2, which is 2. And 4 divided by 2, which is 2. So that is the midpoint. Okay? Now, that's where it's going to reflect over. Okay? I have to find the equation of that line. Now, some of you may know it just by looking at it. But how would we do it? Okay? We would have to use these 2 points, this one and this one, and we need to find the slope. Okay? So to find the slope, remember how you do that? That's the difference in the y's over the difference in the x's. So that's 1 minus 2 over 1 minus 2. And that's negative 1 over negative 1, which is 1. Okay? So that is my slope. So my slope is 1. Okay? And then I have to pick a point. And I have to come up with the equation of the line. So, and when I pick a point, it has to be between the 2 midpoints, because the line is going to go through here, all right? So again, I have to use one of these 2 points, all right? Let's use 2, 2. Okay, so I'm going to use this slope and this point, and I'm going to come up with the equation of the line. So that's when I have to use y minus y1 equals m times x minus x1. So that's going to be y minus 2 equals 1 times x minus 2. Distribute the 1. And then I'm going to add 2 to both sides so that I can get it in slope-intercept form. What happens when I add 2 to both sides? It's 0, right? So the equation is y equals x. All right? Here is the line of reflection right here. Okay? That is the line y equals x. Okay. Now, let's go back up to our coordinates. Do we see a pattern here? They're just flip-flopped, right? So, if we reflect over the line y equals x, then my xy's just switch places. Okay? So if you reflect over the line y equals x, your coordinates just switch places. Okay? So if it reflects over the x-axis, the y changes. If it reflects over the y-axis, the x changes. If it reflects over the line y equals x, they switch places. Okay? And we got one more that has a rule. Okay, what is the reflection rule that maps each triangle onto its image? So the same type of problem, okay? It's the same type of problem, so we're going to do it the same way, okay? All right. Kind of looks like it's going to go right through here, doesn't it? Okay? Because if you look, the C has to map onto C prime, E to E prime, and D to D prime. So you know it's going to go like that. You know it's going to have a negative slope, yes? Okay? All right. So we're going to start again with finding the midpoint. Because again, you've got to find the midpoint between, like, C and C prime and D and D prime. Okay? All right. So midpoint between C and C prime. Remember, you add your x's together. So that's 3 plus a negative 8 divided by 2, and 8 plus a negative 3 divided by 2. 3 plus a negative 8 is a negative 5. Negative 5 divided by 2 is negative 2.5. I'm going to go ahead and put it as a decimal because it turned it. Same thing here. 8 plus a negative 3 is 5. Divided by 2 is 2.5. Okay. All right, so negative 2.5, 2.5. So that would be, that's kind of hard to grab. Right about right there. 2.5, 2.5 is about something like that. Okay, I know, I should have picked better. Alright, so now we're going to look at D and D prime. Okay, so again, 5 plus a negative 12 divided by 2, and 12 plus a negative 5 divided by 2. So this is negative 7 divided by 2, which is negative 3.5, and 7 divided by 2, which is a positive 3.5. So, negative 3.5, positive 3.5. Okay, so this looks like it's the line of reflection right there. So, again, we have to take these 2 points, and we have to find the slope. Okay, so remember, your slope is you subtract 3.5 minus 2.5 and negative 3.5 minus negative 2.5. Well, this ends up being 1 over negative 1, which is what? Negative 1. Okay, so it's got a slope of negative 1, and so now I have to use that slope and one of the points. I'll just use the top one. And now I have to find the equation of the line. Okay? So again, I'm going to do y minus, my y1 is 2.5, equals, my slope is negative 1, and then x minus a negative 2.5. Distribute the negative. Okay, I end up with negative x minus 2.5. I'm going to add 2.5 to both sides. What happens? They cancel. So what do I end up with? Y equals negative x. So it's the same thing, it just has the opposite slope. Okay? So that is my line of reflection. Okay? And remember this point, right? This point, hold on. This acts as the perpendicular bisector between that distance. Okay, remember that. And same thing with the other. Alright? Okay, so going back to look at the numbers, what's happening here? They're flipping and changing signs, right? So if you reflect over the line y equals negative x, your xy flips places and it flips signs. Okay? Alright. So, this is your rule. Alright? This is your rule. You're going to reflect over the x-axis, your y changes signs. You're going to reflect over the y-axis, your x changes signs. You're going to reflect over the line y equals x, flips out places. You reflect over the line y equals negative x, they flip-flop and change signs. You've got to know those 4 things. That's basically what you've got to know for this lesson. Okay? Alright? You won't have any today where you have to do this, really. I mean, there is one you could do it, but I think sometimes, you know, if they give you the coordinates, you can look at them and you can figure out what the change is, okay, if you know the rule. Like, I wouldn't have had to have done all this because I could have looked at those and I see that they switch places and change the signs. I know that that's a reflection over the line y equals negative x. And I wouldn't have had to do all that, okay? So, but then sometimes you don't know what the line is, and so you do have to do that, okay? But if you can recognize it with what they give you, more power to you. That's good, okay? All right. I have one more thing that I'm going to show you, but I'm not going to do it till Monday, okay? Because there's not any of those type of problems on your homework. So